In this video, we're playing around with the BeagleV Fire, and I've just added a small memory to the cape module, which is connected to the processor complex over the APB bus. And so we'll do a little code review of everything I've done there. All right, so first file we're going to review is APB RAM .v. It's a verilog file. And then we'll review cape.v, which is also a verilog file that instantiates APB RAM. And then we will take a look at add_cape, which is a tickle script that tells the build program that APB RAM exists and should be used. And then we'll take a look at some of the C programs I wrote. Probably just work at the memwrite program. All right, so let's edit them. All right, let's see. So here is the APB RAM. It's got an APB bus. It's a fairly straightforward bus. It's got an address, a select line, some enables. I have another video that goes into the bus in detail. It's a really simple block. So every clock cycle, this little guy gets executed. The clock for this design is running at 50 megahertz, so it's executing 50 million times a second. Goes in and looks if the memory write is happening. That is if these three signals are high. And if it is, then whatever's on the write data bus gets put into the memory at the address specified by the P address bus. And we're ignoring the lower 2 bits because we want to just look at the word address, the 32-bit word address, and P adder is a byte address bus. Let's see. And then if we're doing a read, then whatever's in the contents will get put onto the read data bus, out to the APB bus, out to the cape, all the way up to the processor complex. And whenever we're not being accessed, we're driving the bus to 0. Right, that's that bus. Now we go look at the cape. Control F APB RAM. So this guy here. So this is the bus right here. So the RAM is selected whenever the select comes from the processor core. And I'm also qualifying it with these 4 address bits. So if those 4 address bits are a 2, then the RAM is selected. If those 4 bytes are a 1, then the control is selected. And if those 4 bytes are a 0, then the blinky block is selected. And then we get to OR all the outputs together from each one of the blocks, because all the blocks drive 0 when they're when they're not selected. So 0's ORed with something ends up giving you a something. So that'll allow the RAM bus to get onto the APB slate and the APB read data bus and out to the processor. This is just the add cape.tickle file, and you're just adding the cape adding the RAM file to that just so that the build tools know to include it. And then let's see, I wrote a few programs. Let's see, this one here is writes the values from a file into that RAM or into some location. And we'll do a demo of this, but basically the magic. It's a lot of stuff that's probably straightforward, but this is the magic line. There's this mmap routine in Linux that maps physical space to address space. So you tell the number of bytes and the physical hardware address, then it gives you back a virtual address that you can then use, which is then we kind of used up above. Yeah. So that's that guy. And now let's take a look at see if it actually works. And so here we're gonna going over to the Blinky. I'm SSH'd into Blinky, I think. WD, yeah, I'm the Beagle. All right, so all these guys have to be run with a sudo. So let's run. I don't know. Let's run memwrite. Um, so sudo. Sorry, dot memwrite. The address that we just talked about was at 4102.0.0.0.0. Let's give it 4096 range, and let's give it the file name of I don't know. Let's say Blinky hex here, and hit a return. Squirts out, so it writes to these locations. It writes these values. It reads back after it wrote these values. If you really want to see that it's there, though, let's run it again. Let's see, get rid of all of this. I don't know, let's make it much smaller. And I've got a memread routine, which will just read what's in those locations. Oops, sorry, memread. Memread, there it is. And you can see that these values line up with these values. So pretty cool. So we can access the cape and we can write and read to it. I think that's it. Bye.